Draw the graph of any parabola using integers and odd numbers. Let me tell you a very important and unique method to understand how to draw the graph of any parabola using integers and odd numbers. Let's start it. My equation is y equals to x squared, which is the equation of parabola. So the method is in this form. I'm going to put integers, comma, odd numbers into A. These are integers and these are odd numbers. Here is my A, which is +1. Let me put integers, odd numbers, and A. Suppose I have -1, -2, -3. A is 1 and odd numbers are 1, 3, 5. Let me show you the graph of x squared. This is the graph of x squared. When you look to this point, -1, which is my integer, I will have 1 here up to the first point, which is 1, because 1 times 1 is 1. This is the method which can help you to draw the perfect parabola. I have integer on one side, which is -1, -2, -3, and then A, which is 1 here, and odd numbers 1, 3, 5. If I have the graph, this is the graph of x squared. We already know that how to draw the graph. It has been drawn by putting some random values for the x to get the value of y. We have done this how to draw the graph of parabola. In -1, this first integer, which is -1. When I take this first integer, which is -1, I'm gonna go up to -1, -1, negative direction. Look, this integer shows the x-axis values. These odd numbers shows the y-axis values. So up to -1, my y is also 1, because 1 times 1 is 1. So I'm gonna go from the origin up to 1 point, 1. Similarly, when I go up to -2, which is my second point, I'm gonna go up to 3 degrees above the first point based on this odd number 3. When I take the second integer, which is -2, so -1, -2, at this point -2, because 3 times 1 is 3. So I'm gonna go 3 above the second point. I have done from here up to there when I use -1. Now I'm gonna start from here up to there. So I will count 3 degrees, 1, 2, 3. So I will go 3 points above up to here, from here up to there. Similarly, when I go up to -3, which is my third point, I will go up to 5 points above, which is my this 5. I took the third integer, which is -3, which means that I'm gonna go up to -3, -1, -2, -3. So when I choose this -3 at this point, I will go 5 points above this point. 1, 2, 3, 4, 5. I have 5 here. 5 times 1 is 5. That's how you can draw the parabola perfectly. As I told you, my 1 is actually A. Let me explain you again. I want to draw the graph of a parabola using integers and odd numbers. This is my equation, y equals to x squared. I put integer on one side and then odd numbers on another side times A. So let's suppose I have integers -1, -2, -3. My A is 1 here. Odd numbers are 1, 3, 5. When I take the first integer, which is -1, -1. Remember, this represents the y values. So I will go 1 point from here up to there, because 1 times 1 is 1. And when I choose -2, -1, -2 at this point, I will go 3 points above from there. I have done from here up to there for the first term. For the second term, I'm going to start from here up to there. 1, 2, 3. I have 3 here. 3 times 1 is 3. I have done up to here. Now I'm going to start from here up to there. How? When I take -3, -1, -2, -3, I'm going to go 5 points above 1, 2, 3, 4, 5, because I have 5 here. So you always look to these integers and these odd number values. But look, what if I put positive integer 1, 2, 3? This is exactly the same thing, because at +1, I'm gonna go 1 point, 1. At +2, I'm gonna go 3 points from here, 1, 2, 3. At positive 3, from here I'm gonna go 5 points. 1, 2, 3, 4, 5. 5 points. So whether you use positive integers or negative integers, this is exactly one thing. But let me show you a table if you are confused. How I drew this graph. Put some random values for the x to get the value of y. If I substitute x equals to 0, I'm gonna get y equals to 0 as well. My point was here at the origin. By putting x equals to negative 1, negative 1 to the square is positive 1, my y will be positive 1. So my second point was here. By putting negative 2 to the square is positive 4. So my y is 4 here, which is my third point. By putting x equals to negative 3 to the square is positive 9, which is my y value. This is my fourth point. Similarly, when I put x equals to 1, I got my y value equals to 1 as well, which is my this point. By substituting x equals to 2 to the square is positive 4, so my y is 4 here. Here is my place. And then when I substitute x equals to 3 to the square is positive 9, which is my y value. This is my last point. That's how I drew this graph. Then I joined all these points with each other to draw a perfect parabola. I can also use positive integer as well. This integer is nothing new. It's not something that you're gonna put by yourself. These are the coordinate points, are the random values that you put for the x. Negative 1, negative 2, and negative 3. Similarly, you can also put positive 1, positive 2, and positive 3. Another thing that you're gonna check when you draw the graph, a negative 1, if you have this point along y-axis, you must have the same point for the other side as well. Because look, at negative 1, I have 1 for the y. At 1, I have 1 for the y as well. So one is here, one is there. So both the points must be on one place along y-axis. Similarly, when you have this point for the negative side, like when I substitute negative 2, I'm gonna get positive 4. You must have the same point on another side as well, positive 4, because look, by putting x equals to 2, you also have positive 4. So I have positive 4 here and positive 4 here. Therefore, these 2 points must have a common points along y-axis. By putting x equals to negative 3, like at x equals to negative 3, you have 9. The same point you have also for the 3 when you put x equals to positive 3. So 9 is here, 9 is there. Therefore, you must have a common point for both the points on two sides of the parabola. You must be very careful about this thing. One more example, which is 2x squared plus x. This is my new function, which is 2x squared plus x. Let me draw its graph using integers and odd numbers technique, which is integers comma a times odd numbers. These are integers, these are odd numbers. Here is my a is my 2. So I can write 1 comma 2 comma 3 comma 2 into 1 comma 3 comma 5. Look, this time I put positive integers, positive 1, positive 2, positive 3. Last time I had negative 1, negative 2, negative 3. It doesn't matter whether you put negative integers or positive integers, technique is the same. The graph of y equals to 2x squared plus x will be in this shape. This is the graph of 2x squared plus x. It is an upward parabola because the value of a is greater than 0, which is 2. 2 is greater than 0. In case of a which is greater than 0, you will have upward parabola. When I go positive 1 along x-axis, I took the first integer, which is my positive 1 along x-axis, and will go 2 points upward. Remember, don't forget the multiplication of a. This time a is 2, last time I had 1. So 2 times 1 is 2. When I pick the first integer 1, I'm gonna go 2 points in upward direction. By taking the second integer, which is 2, so 2 along x-axis, I will go 6 points upward, because 2 times 3 is 6. Similarly, when I take the third point, which is 3, positive 3 along x-axis, I'm gonna go 10 points along y-axis because 2 times 5 is 10. Let me tell you again how it happened. I have my function y equals to 2x squared plus x. It is a quadratic equation. I want to find its graph, which is a parabola. So the graph of 2x squared plus x is in this shape. Since my a is 2, which is greater than 0, therefore it is an upward parabola. I'm gonna use integers and odd numbers technique. That is integers comma a into odd numbers. So this time I want to put positive integers, positive 1, positive 2 and positive 3, which means that I will follow the right direction of x-axis, which is the positive side. I can also put negative integers, negative 1, negative 2 and negative 3, where I will follow the left side of the x-axis, which is the negative side. For the first integer, which is 1, it means that when I go positive 1 along x-axis, remember these are the x values, these are the y values, positive 1 at this point, I'm gonna go 2 points in upward direction from the origin up to this point. 1, 2. Why? Because I have 2 here, a is 2 here, so 2 times 1 is 2. Therefore I'm gonna go 2 times, not 1 time. 1, 2. Again, don't forget the value of a. It is 2 here. Last time I had 1. Then I picked the second integer, which is 2. It's positive 2. Therefore, positive 2 along x-axis, positive 1, positive 2. At this side, I'm gonna go 6 points in upward direction from this point. Remember, I have done up to here. Now I'm gonna start from here and we'll go 6 points in upward direction. 1, 2, 3, 4, 5, 6. Why? Because 2 times 3 equals to 6. I will go 6 points, not 3 points. 3 times 2 is 6. Don't forget 2. Similarly, when I picked 3, 3 means positive 3 along x-axis, positive 1, positive 2 and positive 3. At this point, I will have 10. I'm gonna go 10 points from here up to there. I have done for the first integer, which is from here to there. Then I did for the second integer from here to there. Now I'm gonna do for the third integer, which will be from here to there. We'll count 10 points along y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because 5 times 2 equals to 10. Don't go 5 points, go 10 points. There is a multiplication of 2 with a 5. 5 times 2 is 10. Look, this is the second method to draw the graph of any parabola by using integers and odd numbers technique. Last time I had this substitution method. When you substitute some random values for the x, you're going to get the values of y. So based on that coordinate points, you draw the graph. But now, this method is a bit simple and straightforward compared to the last one. So whether you apply this method or the substitution method of random values, it depends on you. Both the methods are correct.